This is the fourth note of Unit 3, continuing with this topic of factoring, specifically talking about the greatest common factor. So in the last note, what we did is we talked about 3 different types of factoring. So I just want to review those quick. So the first was trinomial factoring. So trinomial, again, you should know from that first lesson where we defined some terms that is a polynomial, so a set of terms with 3 terms in it. Okay, so when we are factoring a trinomial, this is where we create our little chart, and my chart's going to look a little different than the one on the last slide, but your left column is still going to be your multiplication column, and your right column is going to just be the sum. So we always had to find 2 numbers that multiply to give us C. So C in this case is 12, and we're adding to get 8. Okay, so again, I don't have a whole lot of room here, but this one is pretty simple, right? We know it's not going to be 12 and 1 because that's going to add to 13 or negative 13. So I'm going to move on to 2. I know 2 times 6 will give me 12, and 2 plus 6 gives me that 8. So those have to be my 2 factors. Again, when we're writing that out, it's always just going to be x is going to be the first, and then one of those factors, so plus 2, and x plus 6. Okay, so that's how we factor to trinomial. So multiply to C, add to B. Okay, so those are always the 2 conditions that our numbers have to meet. Okay, the second type of factoring that we looked at was that perfect square trinomial. So remember, that perfect square trinomial, the formula for that was, this is going to factor to equal a plus b squared. Okay, so always going to factor to a plus b squared. Again, if you don't recognize that, just do the chart. That's absolutely fine, right? So we need 2 numbers that multiply to give us 25 and add to give us negative 10. So we know it's not going to be 1 and 25, so our second option would be 5 and 5. So positive 5 and 5 will multiply to give me 25, but will not add to give me negative 10. But what if I throw the negatives on there? Okay, so if I throw negatives on both of those 5s, then it will meet both of those conditions, right? Negative 5 times negative 5 gives me 25. Negative 5 plus negative 5 gives me that negative 10. So we'll see that does end up factoring to the a plus b squared, where a, again, is going to be x, and our b in this case is going to be negative 5. Okay, and remember, we could have just taken the square root of 25 and gotten that 5. All right, and then the sign, again, the reason we knew that this was negative if we didn't actually do our chart is because our b value was negative. So if our b value is negative, our factored form also has to be negative. The third type of factoring that we looked at was that difference of squares. So that's when we have those 2 terms, okay, where the first one is just an x squared and the second is a perfect square. Okay, so that means there's 2 numbers, 2 of the same number, that multiplies together to give us that negative 121. Okay, so the formula for that one, just as a general formula, when we factor it, we're going to get a plus b and a minus b. Okay, so again, to get a, all we have to do is take the square root, the square root of x squared, which is x, and the square root of 121, which is 11. So we have x plus 11 and x minus 11. And again, where did I get those? Square root of x squared is x. Square root of 121 is 11. Okay, again, you could absolutely do your chart here as well. So you would be multiplying to get 121 and adding to get 0. No, yeah. Adding to get 0. Okay, so negative 121. 11 times negative 11 is 121. 11 plus negative 11 gives us that 0. Okay, so we know that those are our two factors. So in this note, so that was all review. That's all from that last note. This is a very quick, short note here. So we're going to be talking about, like I said, that greatest common factor. So we have two different methods of doing this. So before, what we would have done is we would have just rewrote the polynomial in the form x squared plus bx plus c. Okay, and when we do that, we know that we have to find two numbers that multiply to give us c and add to give us b. Okay, and that's from that review. So if we were to do that here, so we're going to take this binomial and we're going to write it in the form of a trinomial. So we know that that's going to be x squared plus 5x, and our c value, because we didn't have one, if we're putting one in, it has to be 0. Okay, so if we were going to find two numbers that multiply to give us c, so we draw our t-chart, multiply to give us c. So they need to multiply to give us 0 and add to give us 5. Well, anything times 0 is 0, right? So we can just simply do 5 times 0. That'll give me 0, and it will also, 5 plus 0 gives me 5. Okay, so that means my two factors are x plus 5 and x plus 0. Okay, but we don't really have to put in the 0. So what this actually is x plus 5 and just an x. Okay, so that's one way to do it. We could basically just turn it into a trinomial and factor it the same way that we've been doing. Okay, another way to look at this is finding the greatest common factor. So what that actually means is we would need to find the largest factor by which we can divide all of the terms. Divide all the terms in the polynomial. Okay, so looking at this one, basically what you are doing is you're saying what is in common between these two terms here. So first you would look at the coefficients, right? So our coefficients here, remember if there isn't anything, there's always a 1. So we have coefficients 1 and 5. Well, the only thing that's common between those is a 1, right? 1 doesn't divide by anything else other than 1. So technically there's no number that we can divide both of those terms by that will help us at all, right? If we divide it by 1, we're just going to get the same thing. So we're just going to be stuck in a loop. So after we look at the coefficients, we change and we look at the variables. Okay, so we look, is there something in common between 1x squared and 5x? So you kind of look at them as like separate terms. Okay, so look at them as kind of separate. So if we're looking at those two things, is there something that's in both? And you should say, yeah, well, if I have x squared, I have an x there, and I also have an x in 5x. So our greatest common factor here would be x. That is the largest thing that we can divide all of those terms by. Okay? The reason our greatest common factor is not x squared is because that 5x only has one x to give. So it can't give two x's if it only has one, right? You can only give me one apple if you only have one. If I ask for 2 apples, you still can only give me 1 apple if you don't have the other. Okay? So that's the reason we're taking out x instead of x squared. So what we need to do is we need to divide all of the terms by x. So I already have my line there. Okay, so divide all terms by x. Okay, so when we do that, whatever we're dividing out has to go out front. So if I'm dividing by x, I need to put an x out front. Okay, this is how we common factor. Put the x out front. Now I need to do x squared divided by x. Well, if I have 2x, right, I have x times x, and I'm going to divide out 1x, that means all I have is 1x left. If I have 5x and I take that x away, that x is now gone, so I'm just going to be left with 5. Okay, and you'll notice that again, regardless of what way you do this, you're going to get the same answer, right? So over on the left, we got x plus 5 times x, and on the right, we also got x times x plus 5. Same thing, okay? And again, if you wanted to check your work, you could just do the opposite. Remember, expanding is the opposite. So if you wanted, you could distribute that. X times x is x squared, so that's good, and x times 5 is 5x, so you'd end up with what you started with. Okay, let's look at a couple different examples here. So we're just going to common factor in these ones. So again, we're just looking for the greatest common factor. So what is, looking at this first one, we have x squared plus 15x. What is the largest thing that you can divide out of both of those? Okay, again, we have 1x squared and 15. So 1 and 15 will both only divide by 1, so that's not going to help us. So after we look at the coefficients, we look at the variables. So I see that I have an x squared and an x. So that means I have an x in both terms. So that's what I'm going to factor out. So I'm going to factor out an x. Remember, when you're common factoring, that means you have to divide all the terms by that x. X squared divided by x leaves me with 1x. 15x divided by x, my x is now gone, right? I've brought it out front. I'm just left with 15. Okay, this next one, I have 4x squared minus 8. So right away, I know I'm not going to be able to take an x out because I don't have an x on that 8, right? That 8 is just simply 8. It doesn't have an x to give. So I look at the numbers. I look, can I divide 4 and negative 8 by the same number? So what number goes into both of those? Okay, the answer there is 4, right? We can do 4 divided by 4 and get a whole number, and we can do negative 8 divided by 4 and get a whole number. So we're going to common factor out just 4. Okay, when I take 4x squared and I divide it by 4, those 4's are going to disappear, right? So I'm only left with x squared. And on my simple calculation here, right, you could just do negative 8 divided by 4 will give you negative 2. Okay, so that's as far as we can go with these ones. That's fully factored. Okay, last one here combines those first two. So we have 3x squared plus 18x. So I know right away that both of those have x's, right? So I'm going to have to take out an x. I know that. But I can also take out the coefficient, right? 18 does divide evenly by 3. So I can also divide them by 3. Okay, so 3x squared divided by 3x. Okay, the 3's will cancel. We'll be taking one of the x's, which means we're left with a single x. Okay, 18 divided by 3 is 6. X divided by x, those are going to cancel, so we're just left with the 6. Okay, so remember, this thing out front is the greatest common factor, and the thing you get that's left over is what's left after you divide. Okay, so we're going to look at one more kind of combination of the last two things we learned. All right, so fully factoring trinomials of the form ax squared plus bx plus c. So this will be very similar to how we factored trinomials in the last note, except there is an extra step. Okay, so I have laid out these steps nicely for you. So the steps to fully factoring in this order. Okay, so we always want to look for a common factor first. So that's what we did right here above. Okay, these examples here were of common factoring. So that's the first thing we're always going to look for. Can I divide all of these terms by a number, by a variable? Okay, so let's just go through these step by step. So step 1, I just want to stick with the same color. Step 1, common factor. So we need to find what is the greatest thing that we can divide all of these terms by and get full whole numbers. So I know right away I can't take out an x, and the reason for that is because my last term here, my negative 60, doesn't have an x to give, right? There's no x on it, so I can't take an x if you don't have it. Okay, so I look for a whole number. Always try to factor out whatever's in front. Okay, so we see we have a 4 out front. So maybe we don't know right off the top of our heads if negative 60 divides by 4 evenly. We probably know that negative 8 does, right? Because we know 4 times 2 is 8. So we would type in our calculator 4 divided by 4. Obviously, that's going to give us a whole number. Negative 8 divided by 4, whole number. Negative 60 divided by 4, whole number. As soon as we know that we can divide all of those terms by 4, we know that that's the greatest thing that we can take out. We know we can't take anything bigger because if the first term only has 4 to give, you can't ask it for 5, right? It only has those 4 that you can have. Okay? So remember, what you're taking out, what you're dividing out is out front. In the bracket is what's left over after you divide. So 4x squared divided by 4 is x squared. Negative 8x divided by 4 is negative 2x. Negative 60 divided by 4 is negative 15. Okay, so that's step 1. We've common factored. All right, and you need to remember that's always going to be the first thing that you look for. Okay, as we go forward and look at some more intense kind of factoring here, and when they're all combined on your assignment, you always want to look to common factor first. Okay, the second step is to check. Can we factor this further? Okay, so if we're comparing it to the examples we just did above, we can't factor any of those any further, right? We don't have a trinomial in our brackets, so we can't go any further. This one, on the other hand, we still have a trinomial, right? In these brackets, that's still a trinomial. So we can try to factor this further, right? So our options for factoring it further, is it a difference of squares? So is it that special case? Is it a perfect square trinomial? Is it that special case? Okay, so remember for both of those, we need to be able to take the square root of 15 and get a whole number. If you try to do that on your calculator, you'll realize that you won't get a whole number, right? What that means is there's not one number that we can multiply by itself to get 15. Okay, so we know right away that we can cancel out option A and option B. So we're moving to our last option. So are there two numbers that will multiply to C and add to give us B? So maybe there is, right? We are going to try. I'm going to create my chart. I know that my two numbers need to multiply to give me negative 15 and add to give me negative 2. Okay, so now we just start. Negative 15 divided by 1, right? So negative 15 divided by 1, that's going to add to negative 14. So we know that's not it. Okay, if we reverse that, if we do 15 times negative 1, it's going to add to give us positive 14. So let's just say, I'll do it in a different color. If I add the negative, I would just get positive 14. Okay, so that's not going to work. So I tried to divide 15 by 2. I don't get a whole number there, right? So I move on to 3. So if I divide it by 3, I'm going to get 5, right? I know that a negative sign has to be on one of these two, right? Because one of them has to be negative for me to get negative 15. It has to be. So for me, I'm just going to guess. So if I put that negative on my 3, so negative 3 times 5 gives me negative 15. Negative 3 plus 5 gives me positive 2. Okay, that's not right? I need it to be negative 2. So instead, what if I put the negative on the 5? So 3 times negative 5 still gives me that negative 15. And 3 plus negative 5 gives me an answer of negative 2. So I know that those have to be my factors. Okay, so I'm going to continue to factor this fully. When I do that, I'm leaving that 4 out front. Okay, instead of rewriting my trinomial, I am going to rewrite my factors. So I'm going to have x plus 3 and x minus 5. Okay, and just as a reminder, we always want to keep the common factor out front. So we're always looking to common factor first. Once we've common factored, we're not necessarily done, right? We need to check if we can continue to fully factor that using the method we used in the last unit, which is finding two numbers that multiply to give you C and add to give you B. So this is the end of the fourth lesson of this unit.